Hi YouTube, it's AC Dodd, and this video is going to be just some little tips about machining on the lathe, in particular parting off. Parting off components on the lathe for a lot of people can represent quite a troublesome activity. So what I'm going to do with this little short video is just give you some tips that I use to make sure that I get nice, easy, trouble-free and damage-free parting. A lot of people I see on YouTube, one of the first things that they do incorrectly is they have far too much parting tool hanging out. And what I mean by that is, you'll see the parting tool out there. Now that may not look like a lot, but that's way too much. The general rule of thumb, and if you get information from people like Sandvik and such, is you don't want any more than 10 times the width of the cutting tool hanging out the end of your holder. So in reality, with these carbide inserts and for that matter high-speed steel, what you actually want to be doing is withdrawing that in to the holder for the maximum support. So even when doing relatively simple stuff, you actually only want to be having the bare minimum of tool hanging out the end of that holder to maximize the rigidity, because most people in home lathes don't have big lathes. This is a Colchester student, and she's quite big for a home lathe. It's not as big as some people have, but most people have smaller lathes than this. So successful parting is all about rigidity, and when you have got a small lathe, you need to do everything you can to maximize that. So the first thing to do is to minimize how much tool stick out you have. The other thing you want to do is to make sure you don't have too much hanging out here. Again, I'll see on YouTube, there's other videos and they got, the workpiece is all the way out here and they're trying to part off from the end, you're just making life hard for yourself. So only have enough stock material hanging out at the end that you need to part off. Now, I'm just parting off a few washers, so in this case, a few spacers, sorry. So in this case, I've just put enough out, hanging out to do that. Obviously, the more hanging out that you've got, the less support there is in the workpiece and the more liable you are to produce chatter. One of the other things that people often put up as a blocker to successful parting is the wear on the machine. Well, my machine's no exception, so if I just rock that backwards and forwards, listen. If we just look at that up there, you can see those numbers moving backwards and forwards. There's about 1 millimetre of play in my cross slide, and that has no effect on the how well this machine parts off. One of the next things you need to look at or think about is the width of your cutting tool. Now, if you've got 3mm, then I'm afraid you're going to struggle on a home lathe. So you need as narrow as you can get, so the narrower the better. This is a 2mm one and it works perfectly on this Colchester lathe. The other thing is you also need to make sure you've got the right cutting bits for the material that you're cutting. This is a steel insert from Corloy and the SP200 range, and these work very well. So this is the pack of inserts that I use for mine for cutting steel. And as you can see, it's a Corloy insert SP200 NC3220, which is neither hard nor soft. It's an in-between carbide, which means it's as tough as well as hard. So it's a combination of both, and that's what you need when you're parting, because it's quite a violent operation, and if you have any chatter and things like that, it can actually chip the end of the insert. So the last thing you want is something that's very hard. The other thing to take note there for when we actually start cutting is the feed rate, and the recommended feed rate there is 0.02 to 0.15 millimeters per rev, and the speed range 150 to 290 meters per minute. Now, one of the other things that might be obvious, but you need to make sure that your tool tip is on centre line with the workpiece. Obviously, if that's a little bit above or a little bit below, you're going to run into problems. So spend a bit of time making sure that's on centre line with your workpiece. And also, you want to make sure that that tool is in alignment. So it's not like this, or it's not the other way. So square it up with the front edge of the work, so that your tool feeds in nice and square to the axis of the machine and parts off, produces a cut which doesn't make the tip rub on the side of the workface. Of course, one of the biggest things that people don't do on a home lathe is they don't use the feed. Now, in my experience, this is critical. Using the feed is the secret, or one of the biggest secrets to success of parting off. If you imagine a CNC machine, that parts off perfectly fine on feed. All you need to do is reproduce that on your home lathe and set the appropriate feed and the appropriate speed, and you will part off perfectly every time. So I'll just talk you through the setup we've got here. We've got my 2mm parting tool set up. I've got it in the appropriate position where I want the machine to part off the item that I need. The part that I need, I'm just making spacers. I've also got a piece of silver steel here up the middle to catch the items as they're parted off so they don't go flying. The other thing is I've obviously got the machine set and the feed set, and in this case I'm actually using about 105 meters a minute on this, which is about 1700 RPM, and we're going to use a feed rate of 0.058 millimeters per rev. As you can see, that actually chipped beautifully there, and obviously the colour of the chips is nice. They're parted off with no drama, and it was kept and captured on the bar. So we'll just take that out. So that's the piece we cut off. I'll just check the measurements. It's a little bit warm, obviously, as you can imagine, but I'm not having to face the sides. That's literally straight off the parting tool. It's not an ideal perfect finish, but it's plenty good enough for the spacers I need, and hopefully it's the right width, so we'll measure that now. My target here was 265 thou. As you can see, we got 266, so that's perfect. Okay, so let's part off the last one that I need. Again, no coolant. Don't need to do it on little jobs like this. Again, no hassle. Leaves a nice finish on the next on the original bar, so that the next one doesn't need finishing. You know, whenever you're trying to set your machine up, you want to minimise the amount of work you need to do, and if you have to reface the bar after every one, that just adds time to the job and kind of shows that you haven't really got the control right in your machining process. One of the other things you want to think about when you're parting off is try not to part off you know, all the way through the bar. Always part off to a hole, because you'll find that if you try and part off all the way to the middle, the surface speed is so slow in the middle, it puts a lot of stress on the carbide insert. So the best thing to do is if you're on a CNC machine, that's easy to achieve because you can obviously speed the machine up, but you can also back the feed off, where that's not so easy on a manual machine, because that means you have to stop, which is not ideal. So the best thing to do on a manual lathe like this one is just part off into a hole and have a reasonable size hole up the middle. I appreciate that's not always possible depending on the parts you're making, but try and engineer that into your machining operation if you can. Back to the speeds here. It says you know, the average speed is 220 meters a minute. That's actually very fast, and much faster than most machines can go. I'm using a 20mm diameter metal that I was parting off there, and I'm using 1700 RPM, which I think is about 105 meters a minute or something like that, but it's close around that. If you're using carbide, you want to be running around 100 meters a minute for sort of mild steel. This was E&8 steel, or 1040, that I was cutting off, and it cuts ideal around 100 meters a minute. Yes, you can go faster, but if you're going to run at that sort of speed, 150 to 290 as it says there, you really need to be using coolant to maximise the life of your tip. If you're running around 100 meters a minute, which is what I tend to do for a lot of parting operations on most steels, then if you're running at that speed, the tip life's actually not too bad. So that insert has lasted me literally a year in that parting tool. So yeah, they last a long time if you load them properly. The reason for using the feeds rather than hand feeding it is you need to load the tool to stop it vibrating. So if you just let that rub on the surface, it will vibrate. So the idea there is to put the feed rate in such that it loads the tool down and keeps the tip pressed into the workpiece, and keeps that constant. That's really the biggest trick with parting. Well, I hope you found that useful. There's some of my tips for successful parting on the lathe. I say I've been doing this a long time now, and I've got a fairly good handle on certainly what makes my machine and a few other machines work properly. But hopefully you find that useful. And as ever, like and subscribe if you want to see more. Thank you very much.